We all know about Yellowstone, right? That massive, slumbering giant under Wyoming that could, theoretically, have a really, really bad day. It's the poster child for supervolcanoes. But what if I told you that Yellowstone is just one chapter in a much bigger, more explosive story? What if our planet is hiding the ghosts of even bigger eruptions, ancient cataclysms that dwarf anything we can imagine? Today, we're going on a geological detective mission to uncover Earth's lost supervolcanoes. So, first things first. What exactly makes a volcano super? It's not just about a big mountain going boom. The official scale is the Volcano Explosivity Index, or VEI. A super eruption is a VEI 8, the biggest one on the chart. We're talking about an eruption that blasts out over 1,000 cubic kilometers of material. To put that in perspective, that's enough ash and rock to bury the entire state of Texas under several feet of debris. These aren't just eruptions, they're planet-altering events. The thing about super eruptions is they don't leave behind a classic, cone-shaped mountain like Mount Fuji. They're so powerful they literally blow the ground apart and then collapse in on themselves, forming a massive crater called a caldera. Yellowstone is a great example. The park is basically just one huge caldera, but over millions of years these calderas can be eroded away, buried under new layers of rock or filled in by lakes and forests, effectively vanishing from sight. So how do we find these geological ghosts? Geologists are like detectives for the planet. They don't look for a giant crater, they look for the evidence left behind. Their main clue is something called an ignimbrite sheet. Imagine a pyroclastic flow, a superheated, fast-moving cloud of ash, gas, and rock that's so enormous it covers thousands of square miles. When this material settles and cools, it fuses into a solid layer of rock. By finding and mapping these vast ignimbrite sheets, scientists can trace them back to their source and calculate the sheer scale of the ancient eruption. It's like finding a giant splash pattern and working backward to figure out how big the rock was that hit the water. Let's travel to the American West, specifically Colorado. Hidden in the San Juan Mountains is the Garita Caldera. You've probably never heard of it, but around 28 million years ago, it produced the single largest explosive eruption known to science. The Fish Canyon Tuff, which is the ignimbrite sheet it left behind, covers a staggering area. We're talking an eruption that ejected over 5,000 cubic kilometers of material. That's 5 times bigger than the last major Yellowstone eruption. It was so immense that for a long time geologists couldn't believe it came from a single source. They thought it had to be multiple volcanoes erupting at once, but the chemical fingerprint of the rock told a different story. It all came from one unimaginably massive event. Now let's head across the Pacific to Indonesia. We know about the Toba eruption 74,000 years ago, which created the beautiful Lake Toba. That was a VEI 8 that plunged the planet into a volcanic winter and may have created a major bottleneck in human evolution. But even Toba might have older, bigger siblings. The rocks around Sumatra and the surrounding islands hold clues to other, more ancient super-eruptions. The challenge here is that the region is so geologically active, with tectonic plates constantly shifting and volcanoes constantly building new land, that the evidence gets buried or recycled back into the Earth's mantle. It's a geological cold case with clues disappearing all the time. So why does finding these lost supervolcanoes even matter? It's not just about satisfying our curiosity for disaster stories. Studying these ancient events helps us understand the full range of what our planet is capable of. It helps us model how the climate responds to massive ash injections into the atmosphere. How long does a volcanic winter last? How severely does it impact life? The answers are written in the rock layers left behind by these ancient giants. Each ignimbrite sheet is like a page in Earth's diary. By analyzing the chemistry of the rock, the size of the crystals and the layers of ash found across the globe in sediment cores, we can reconstruct the event. We can figure out how quickly the magma chamber emptied, how high the ash plume reached, and how far the fallout spread. This data is absolutely crucial for improving our hazard assessments for modern supervolcanoes like Yellowstone. The past is the key to understanding the future. Think about it this way. The geological record shows us that these monster eruptions are a natural, recurring part of our planet's life cycle. They happen on timescales of hundreds of thousands of years, far beyond human experience. We see Yellowstone, and we think it's the ultimate threat. But the Earth has produced events that make Yellowstone look modest. Finding the La Garitas and the ancient Tobas of the world reminds us that we live on a dynamic, powerful, and sometimes incredibly violent planet. It's a humbling perspective. We build our cities and our lives on the surface, often forgetting the immense heat and pressure churning just a few miles beneath our feet. These lost supervolcanoes are not just historical curiosities. They are solemn reminders of the immense forces that have shaped our world and will continue to shape it long after we're gone. They are the sleeping giants of Earth's deep past, and their stories are a vital part of understanding our home. Thank you so much for joining me on this geological journey today. If you found this as fascinating as I do, please hit that like button, subscribe for more deep dives into our amazing planet, and ring that notification bell. Let me know in the comments which geological mystery you'd like us to explore next. Stay curious, and I'll see you in the next video.